Hello, this is the 2003 AMC 12A problem number 25. I've gone from, on this 2003 AMC 12A, from 1 up until 25 by now. Let f of x be the root of ax squared plus bx. For how many real values a is there at least one positive value of b for which the domain of f and the range of f are in the same set? Okay. So the function f of x equals the root of quantity ax squared plus bx has a codomain of all non-negative numbers, which basically means that 0 is going to be greater than or equal to f of x. Okay, and since the domain and range of f are the same, it follows that the domain of f would also be 0 is less than or equal to x. Okay, now we're going to get into the juicy stuff. The function has two zeros. One would be, since you can factor this into x times ax plus b, you can see that it has two zeros, one at when x equals 0 and the other when x is minus b over a, which must be part of the domain. Since the domain and the range are the same set, it follows that minus b over a is in the codomain of f, which you can just replace this over here, where 0 is less than or equal to minus b over a. This implies that exactly one of them is going to be negative and the other is going to be positive. Okay, now the problem says that there is at least one positive value of b that works, thus a must be non-positive, b is non-negative, and the domain of the function occurs when x times ax plus b quantity is greater than 0. Another way you can write that is with our newfound statement. Now, if you look back on here, we can complete the square. I'm going to say f of x equals big root over here, a x plus b over 2a squared minus b squared over 4a. It's going to be less than or equal to the root of minus b squared over 4a. And now you can use a trivial inequality, as long as you remember that a is going to be less than or equal to 0. Or that was using the trivial inequality. Now, since f is continuous, and it assumes its maximum value when x equals minus b over 2a, it means that the range of f is going to be something looking like this. Okay, and as the domain and the range are in the same, we have minus b over a equals root of minus b squared over 4a, which is equal to b over 2 root minus a. And that, doing a bit of algebra, means that a times a plus 4 equals 0. We can divide through by b, since it's given that b is positive, so that doesn't really matter. You get the solutions where a equals 0 or 4, and you can go back in and plug to make sure that it works, which it does. And your answer is going to be 2, which is C, but we are going to write 2 because I didn't put the answers there. So anyways, thank you much for watching all 25 videos of these. Thank you much for watching. Goodbye.